Hi, this is the second video, so lesson 2 of P1, and this is all about stars. Keywords we're going to cover are asteroid, comet, fusion, dwarf planet, nucleus and light pollution. So let's take a closer look at our solar system. Our solar system consists of our sun, which contains about 99 or more percent of the mass of the solar system is contained in the sun. And obviously the sun is very, very hot, and the reason the sun is hot is because of the process that's going on in the nucleus of the sun, which is called nuclear fusion. Now in nuclear fusion, in simple terms, hydrogen atoms or versions of hydrogen are combining together to make helium, and when hydrogen combines together to make helium, what's released is lots of energy, and we'll deal with why lots of energy is released later on. But for now we need to understand the idea nuclear fusion. Fuse means to join, so hydrogens joining together to make helium, releasing lots of energy in the centre of the sun, and that energy radiates outwards through the sun and creates the light that we use to see during the daytime. Now obviously we have the planets of the solar system, but which orbit roughly in circles. So planets in the solar system orbit roughly in circles. To be more precise, they are ellipses, but they are very regular, almost fully circular ellipses. As well as the planets orbiting the sun, we have the dwarf planets. And as you know, Pluto was downgraded to a dwarf planet simply because there were planets of a similar size to Pluto discovered in the solar system more recently, but they weren't big enough to be planets, so the category of dwarf planets was created in order then to include Pluto. So we have 3 dwarf planets in our solar system and 8 planets. In addition to that, we have asteroids and comets. Now, an asteroid is a lump of rock, and most of the asteroids live between Mars and Jupiter. So outside the orbit of Mars. So if that's the orbit of Mars, and then outside of Mars we have these rocks, some of them very large, some of them tiny, all orbiting round. And they again orbit roughly in a circle or an ellipse. In addition to that, to asteroids, we have comets. Now comets are made of dust and ice, and we don't see them all that often, but when you do, they can be very spectacular. Now if I'm going to draw very quickly the orbit of a comet's orbit will be very, very elliptical, so it will come in very close to the sun, around the back of the sun, and then back out again, and it can then disappear off for decades or longer before it comes swooping back in again. Now comets always have a tail, and that tail always points away from the sun because of what we call the solar wind, which is the particles ejected from the sun and which melt the ice on the surface, forming this trail that forms behind it. And as I say, the trail always points away from the sun, not necessarily means that the trail doesn't necessarily fall behind the sun. If we have, when the comet reaches down here and it's going away from the sun, then the tail will be in front of the sun. So comets made of dust and ice, highly elliptical orbits, so I think much more like a rugby ball shape rather than a football shape. So as opposed to planets whose ellipses are almost circular. Okay, so just to recap again. The sun is at the centre of our solar system, containing almost all the mass. The reason it's so hot is because of the process of nuclear fusion. Nuclear fusion is the joining of two small nuclei to form a larger one, in this case hydrogen forming helium. We have 3 dwarf planets, we have 8 regular planets, we have asteroids orbiting just outside Mars, we have comets which come into and go out of the solar system at regular intervals. One last thing, which is just about light pollution. So obviously everything we know about stars has come from astronomy. We haven't visited stars, we've sent probes towards the sun but not that near, so everything we know about the stars comes from astronomy. Now astronomers normally like to work in places which are dark and at high altitude. Now the reason for that is obviously when it's dark we can see more clearly. If there's lots of light on, for example, if you're trying to look at stars in a city, you're trying to look at very dim light coming from the stars, and it's no good if there's street lamps on and buildings with their lights on. So if there's lots of light around, we call that light pollution. Obviously astronomers want to work away from the light pollution. They want a clear view of the night sky so they can analyse the light. So we have light pollution, we also have dust in the atmosphere. So the higher the altitude we can, ideally near the top of a mountain, not only is there less dust in the way, but also if there's weather and you're high enough, if you forgive my terrible clouds, you can be observing from above the weather. So astronomers like to work in dark places at high altitude where there's very little light pollution and not so much of the atmosphere to look through, because the atmosphere contains dust and moisture which can distort and absorb the light coming from the stars. Remember, this light is very, very faint. It's travelled for great distances.